integrate 1 over x positive 1 whole to the third power times x positive 2 dx. To integrate this rational function, I'm going to write this rational function into partial fractions. So 1 over x positive 1 whole to the third power times x positive 2. Okay, to write this rational function into partial fractions, first we have to look at the denominator. So the denominator is a product of two binomials, and particularly in the first binomial, we have the exponent 3. Since the exponent of the first binomial is 3, we have to write 3 fractions for it. Okay, when I look at the exponent of the variable in the first binomial, it's just 1. Since the exponent of the variable in the first binomial is 1, I have to take a single constant as numerator for each of these 3 fractions. So I'm taking the constant, unknown constant A as numerator for the first one, and B for the second one, and C for the third one. Okay, now for the first fraction, the denominator should be the binomial, the first binomial with the exponent 1. So that's just x positive 1. For the second fraction, the denominator is the same first binomial with exponent 2, that is x plus 1 the whole square. For the third one, x plus 1 whole to the third power. Okay, now I have to look at the second binomial, that is x positive 2. So the second binomial is having the exponent 1. So I have to write just only one fraction for it. Since the exponent of the variable in the second binomial is also 1, I have to write a single constant as numerator, and the same binomial should be taken as denominator. So now I have done the given rational function into partial fractions. Now my aim is to find the values of these 4 unknown constants. For that, I have to simplify the addition of these 4 fractions. For that, I have to get the least common multiple of the 4 denominators. That's nothing but the one what we have on the left side over here, that is x positive 1 whole to the third power times x positive 2. So that is, I have to get this one, x positive 1 whole to the third power times x positive 2 as a denominator for each of the 4 fractions we have on the right side. Okay, let me do it. Okay, to get this one as a fraction, to get this one as a denominator for the first fraction over here, so what I should multiply both numerator and denominator of the first fraction. So I have to multiply x positive 1 whole to the second power times x positive 2. Okay, let me write the second fraction, which is b over x positive 1 whole to the second power. So here, the second fraction, I need to multiply both numerator and denominator by x positive 1 times x positive 2. Okay, the third fraction. So here in the third fraction, I need to multiply both numerator and denominator by just x positive 2. So in the fourth one, already we have x positive 2. So I need to multiply both numerator and denominator by x positive 1 whole to the third power. So 1 over x positive 1 whole to the third power times x positive 2 is equal to, now just look at the denominator of each fraction. All of them are x positive 1 whole cube times x positive 2. So we can take the denominator in common, that is x positive 1 whole to the third power times x positive 2. And the numerator of the first fraction is a times x positive 1 the whole square times x positive 2 positive. The numerator of the second fraction is b times x positive 1 times x positive 2 positive. The numerator of the third fraction is c times x positive 2. And the numerator of the fourth fraction is d times x positive 1 whole to the third power. So here, the fraction on the left side and the fraction on the right side have the same denominator, so we can cancel out. So we get 1 on the left side. On the right side, we have a times x positive 1 whole to the second power times x positive 2 positive b times x positive 1 times x positive 2 positive c times x positive 2 positive d times x positive 1 whole to the third power. Okay, let's continue this one on the next page. To get the values of the four unknown constants A, B, C, and D, I have to plug in some random value for x such that any three out of these four unknown constant must vanish. And so that I'll be able to get the value of the fourth unknown constant. Okay, here if I substitute x is equal to -1, what will happen? So if I plug in x is equal to -1, so this part will become 0. -1 positive will become 0. So A will vanish. The same thing we'll have for the second term, because this part will become 0, B will vanish. And -1 positive 1 here will become 0. So D will vanish. I'll be able to get the value of C. So if I plug in x is equal to -1, so A, B, and D will vanish. I'll be getting the values of I'll be getting the value of C. So 1 is equal to, so -1 positive 1. This part will completely become 0. Positive. So -1 positive 1 here, it will become 0. 0 multiplied by anything, 0. Positive. -1 positive 2, that is C times -1 positive 2 positive. So this -1 positive 1 will become 0. 0 multiplied by D becomes 0. So now the three constants A, B, and D vanish, and I get the value of C. So 1 is equal to C times -1 positive 2 will become just 1. So finally I get C is equal to 1, because C times 1 is C. C is equal to 1. Okay, in this way, now I have to plug in some other value for x, so that the three unknown constant must become 0, so that I'll be getting the value of the fourth unknown constant. So if I plug in x is equal to -2, so this part will become 0, so A will vanish. So here this part will become 0, B will vanish, this part will become 0, C will vanish. I'll be getting the value of D. Okay, now let me plug in x is equal to -2. So 1 is equal to, so -2 means -2 positive 2 will become 0. 0 multiplied by anything will be 0. The same thing we have for this one, and for this one, and for D, we have D times -2 positive 1 whole to the third power. So D times -2 positive 1 will be -1 whole to the third power. So 1 is equal to D times -1. Then I get 1 is equal to D times -1 is -D. I need the value of D, but here I have -D. So to get rid of this negative sign, I multiply both sides by -1. I get -1 is equal to D, or D is equal to -1. So I got the values of C and D. C is equal to 1 and D is equal to -1. Okay, still I have to get the values of the two unknown constants A and B. For example, if I want to get the value of A, I have to assign some value for x, so that B, C, D, all these three unknown constants must become 0. I mean, they must vanish. So if I assign x is equal to -1 or x is equal to -2, so B will vanish. But what will happen here is, when I plug in x is equal to -1 or -2, in both the cases, A also will vanish. So the idea of what I've applied so far to get the values of C and D will not work anymore to get the values of A and B. So we need to use some other strategy to get the values of A and B. So let me continue this one on the next page. Okay, here if I plug in x is equal to 0, what will happen? So no unknown constant will become 0. All the four unknown constants will appear in the equation. So in that case, I can plug in the values for C and D, which I've already got it. So then I'll be getting an equation in terms of A and B. Again, I have to plug in some other value for x, so that all the four unknown constants will appear in the equation. I have to plug in the values for C and D. So I'll be getting one more equation in terms of A and B. Then I have to solve the system for A and B. Okay, let me continue this. So now I'm going to plug in x is equal to 0. So 1 is equal to, if I plug in x is equal to 0, this one will become 0 plus 1 will be 1. So that's 1 square. 1 square is just 1. And 0 positive 2 is just 2. Positive B times 0 positive 1 is 1. 0 positive 2 is 2. So it's going to be 1 times 2 positive. C times 0 positive 2 will be 2. Positive D times 0 positive 1 will be 1. 1 to the third power will be 1. So 1 is equal to 1 times 2 is 2. 2 times A is 2A. The same thing I have here, 2B, positive 2C, positive D. Okay, so I know the values for C and D. C is equal to 1 and D is equal to -1. I can plug in, 1 second. Okay, here I can plug in C is equal to 1 and D is equal to -1. When I do it, so I'll be getting 2 times 1 positive, D is -1. So 1 is equal to 2A positive 2B. Positive 2 times 1 is 2 and positive times negative will become -1. So 1 is equal to 2A positive 2B. So when I combine 2 and -1, it's just 1. So I subtract 1 from both sides. So positive 1 and -1 cancel the same thing. So 0 is equal to 2A positive 2B. Or we can write this one as 2A positive 2B is equal to 0. So this one, everything is a multiple of 2. So I can divide the whole equation by 2. So 2 will cancel out. Here 2 will cancel out. I get A positive B is equal to 0 2 is 0. I consider this is equation number 1. Okay, as I plugged in x is equal to 0, I have to plug in some other random value for x so that all the 4 known constants A, B, C, D will appear in the equation. Again, I have to do the same thing. I have to plug in the values for C and D. I'll be getting one more equation in terms of A and B like this. So then I'll have a system of 2 equations with 2 unknowns A and B. So I have to solve for A and B. Okay, let me continue this one on the next page. Here I am going to plug in x is equal to 1 so that all the 4 constants A, B, C, D will appear in the equation. So 1 is equal to A times. When I plug in x is equal to 1, this part will become to 1 plus 1, 2. And we have a square. So 2 square is 4. And this part 1 plus 2 will be 3 positive B times 1 positive 1 will be 2. 1 positive 2 will be 3 positive C times 1 positive 2 will be 3 positive D times 1 positive 1 will be 2 and 2 to the third power will be 8. So 1 is equal to 4 times 3 is 12A positive 2 times 3 is 6B positive 3C positive 8D. Okay, now I can substitute the values for C and D. C is equal to 1 and D is equal to -1. Already we got these two values. So 1 is equal to 12A positive 6B positive 3 times. For C, we have to plug in 1 and for D, we have to plug in -1. So 1 is equal to 12A positive 6B positive 3. So positive times -1, negative will become negative. 8 times 1 is 8. So 1 is equal to 12A positive 6B. When I combine these two, I'll be getting -5. Okay, I'm adding 5 to both sides. So -5, +5 will cancel out, and 1 plus 5 becomes 6 is equal to 12A positive 6B. Or I can write this equation as 12A positive 6B is equal to 6. So when I look at these numbers, all of them are multiples of 6. So I divide the complete equation by 6. So 6 goes into 6 one time, 6 goes into 12 two times. I get 2A, 6 will cancel out. Here 6 will cancel out. 2A positive B is equal to 1. So this is equation number 2. Okay, now we have two equations. Already we got one equation in terms of A and B, the first equation. Now I got the second equation in terms of A and B. I have a system of 2 equations with 2 unknowns A and B. I have to solve this system of 2 equations for A and B. Okay, let me continue this one on the next page. Here we have the system of 2 equations with 2 unknowns A and B. Okay, now I have to solve the system for A and B. Okay, I write the second equation as it is. It is 2A positive B is equal to 1. I'm going to multiply the first equation by -1 so that I'll be able to eliminate the constant B. I can get the value of A. So I multiply the first equation by -1. So when I multiply this part by -1, I'll be getting -A, -B. On the right side, we have 0. So positive B, negative B will cancel out. When I combine 2A and -A, it will be just A. And when I combine 1 and 0, I get 1. So I got A is equal to 1. Okay, to get the value of B, I can plug in A is equal to 1 into one of the 2 equations we have over here to get the value of B. I'm going to plug in a is equal to 1 into the first equation. So 1 positive b is equal to 0. So I subtract 1 from both sides. So I'm getting b is equal to -1. So I got the value of b. So now I have the values of all the 4 unknown constants. So they are a is equal to 1, b is equal to -1, c is equal to 1, and d is equal to -1. Okay, now let's go back to the original question. So already we have split up the given rational function into partial fractions with these constants a, b, c, d, and we have to plug in the values for these 4 constants a, b, c, d, and let's proceed the integration. Okay, here we have to substitute the values for a, b, c, and d, and for a we have to plug in 1 for b, -1 for c, 1 for d, -1. So in the next step, it will be 1 over x positive 1 whole to the third power times x positive 2 equals to, so 1 over x positive 1, positive times negative become negative, 1 over x positive 1 whole to the second power, positive 1 over x positive 1 whole to the third power, positive times negative become negative 1 over x positive 2. Okay, now we can integrate both sides with respect to x. So here integral we have on the left side, and let's check integral on the right side. Okay, here we can distribute this integration to each fraction. Then we'll be getting integral 1 over x positive 1 dx negative integral 1 over x positive 1 whole square dx positive integral 1 over x positive 1 whole to the third power dx negative integral 1 over x positive 2 dx. Okay, here if you consider the first integral, the denominator is x positive 1. So if I find the derivative of x positive 1 with respect to x is just 1, that we have in numerator. Whenever we have the derivative of the denominator in numerator, the integration of such rational function is natural logarithm of what we have in denominator, that is x plus 1. So the integration of 1 over x positive 1 dx is equal to natural logarithm of x positive 1. Already we know that logarithm is defined only for positive values. So this x positive 1 always has to be positive. For some value of x, if x positive 1 becomes negative, it has to be considered as positive. So for that, we have to take absolute sign for this x positive 1. So ln of absolute value of x positive 1. So because for some value of x, even if it becomes negative, so because of the absolute sign, it will become positive because we have natural logarithm over here. So logarithm is defined only for positive values. So always it has to be positive. Okay, negative. Okay, here I cannot apply the same idea for this integration what I've applied for the first integration, because here the exponent of this x positive 1 is 2. So before we proceed this integration, let's move this term to numerator. If I move this term to numerator, the exponent 2 will change its sign. Already it's positive 2, it will become -2. Then we have dx. The same thing we have for this one. Then we get positive integral x positive 1 whole to the negative third power dx. And here the derivative of this x positive 2 with respect to x is just 1, that we have in numerator. So the integration of this one is this rational function is natural logarithm of absolute value of x positive 2 positive c. Okay, we got the integration of the first one and the last one. Still we have to get integration for the middle two parts. Okay, so here when I look at the second integration, here we have a linear function with the exponent -2. The third integration, I have a linear function x positive 1 with the exponent -3. Now let's look at the stuff on integrating a linear function to the nth power. Integral ax positive b to the nth power dx. Here we have a linear function, that is ax positive b, and the exponent is n. So to integrate this linear function ax positive to the x positive b to the nth power, so what we need to do is ax positive b to the power n plus 1. That is, I have to add 1 to the existing exponent n, then it will become n positive 1. I have to divide by the same exponent, that is n positive 1. Further, I need to multiply this n positive 1 by the coefficient of a. plus c. So the integration of the linear function ax positive b to the nth power is equal to ax positive b, add 1 to the exponent and divide by n positive 1, multiply this n positive 1 by the coefficient of x. Let's apply the same idea in our problem. Okay, here we have a linear function exponent negative 2. Let's see how it can be integrated using the idea of what we have seen so far. So natural logarithm of x positive 1, natural logarithm of absolute value of x positive 1 negative x positive 1 whole to the power. So now what I need to do is I have to add 1 to this exponent, negative 2 positive 1 over negative 2 positive 1. I have to multiply this one by the coefficient of x, which is 1 positive. The same thing I have to do here. I have to add 1 to the exponent, negative 3 positive 1 over negative 3 positive 1. And it has to be multiplied by the coefficient of x, that is 1, negative ln of absolute value of x positive 2 positive c. Okay, here ln of absolute value of x positive 1 and negative x positive 1. So the simplification of this one is negative 1 over the simplification of this one is negative 1 times negative 1 positive x positive 1. The simplification of this one is negative 2 over 1 times negative 2 negative ln of absolute value of x positive 2 positive c. Okay, let me continue on the next page. Here we have a step from the previous page. So I think we can write these two natural logarithms together. So I get ln of absolute value of x positive 1 negative ln of absolute value of x positive 2, and this negative times negative will become positive, and it can be moved to the denominator because the exponent is negative 1. When I move this one to denominator, so the exponent negative 1 will change its sign to positive. So I'll be getting 1 over x positive 1, and negative times positive become negative. So here the exponent is negative, so I can move this term to denominator. So when I move this one to denominator, so the exponent negative 2 will change its sign to positive. So I get 1 over 2 times x positive 1 go to the second power positive c. Here we can use the coefficient rule of logarithm. So because the two logarithms are in subtraction, so we can write logarithm once, we can divide the arguments. So I'll be getting absolute value of x positive 1 over absolute value of x positive 2 positive. Here, to simplify these two fractions, I need to get the same denominator. So here I have 2 times x positive 1 whole square. So here I can get the same denominator 2 times x positive 1 whole square by multiplying this denominator by 2 times x positive 1. That is, I multiply both numerator and denominator by 2 times x positive 1. So when I do so, I'll be getting 2 times x positive 1 over 2 times x positive 1 the whole square, negative 1 over 2 times x positive 1 the whole square positive c. Okay, here we divide two absolute values. Whenever we divide two absolute values, we can take absolute value in common. So natural logarithm of absolute value of x positive 1 over x positive 2 positive. Here the two fractions are the same denominator. We can take common denominator, that is 2 times x positive 1 the whole square, 2 times x positive 1 negative 1 positive c. So the next step, it will be ln of x positive ln of absolute value of x positive 1 over x positive 2 positive. So let's simplify this one. So it's going to be 2 times x positive 1 negative 1. So 2x, if I distribute 2 to x positive 1, it will be 2x positive 2 negative 1. So finally it becomes 2x positive 1. So the simplification of this part is 2x plus 1 over 2 times x positive 1 the whole square positive c. So this is the result of the given integration.